Good afternoon, class. Here's exam 4 review covering chapters 4 and 5. Here's the second part. We're going to cover from 4.4 all the way to 5.4. Fractional format. This is a rational function. This is not. Both of them are fractional format. If you can't simplify it, the choice for you would be the denominator. The derivative is e to the power of t, therefore du is e to the power of t dt. dt belongs to the numerator. We rewrite it so it becomes clear that we are dealing with du over u. And that follows, the answer is natural log of u plus a constant in an absolute value. The u is replaced by 5 plus e to the power of t, and we are done. Because this expression is positive, you could lose the absolute value. Any rational function, any fractional format can be simplified first. This can't be factored out because this quadratic expression has a equals 1, b equals 2, c equals -1, b squared minus 4ac is 2 squared minus 4 times 1 times -1 makes it positive 8. Now positive 8, if it's not a perfect square number such as 1, 4, 9, 16, and so forth, cannot be factored. So the choice, the denominator is the choice for you. If I differentiate that, du dx is 2x plus 2, or 2 times x plus 1. Therefore, du is the same thing times dx. Dx belongs to the numerator. We put it at top. So when we compare it to du, number 2 is missing. Remember, in many texts, they solve for dx, but this is much easier. Just plug in 2 and undo it with its reciprocal 1/2. And this part looks like this, du over u, and that is a natural log. So 1/2 natural log of absolute value of u plus a constant. You replace the u and you keep the absolute value sign because this expression can be negative or positive, and therefore you're done. I want to look at the reciprocal of one of them. For example, this one. You don't need substitution. Rather, you want to go with two fractions. This is 5e to the power minus t. This is simply 1. Because we are integrating, we divide by -1. This results in -5e to the power minus t, and this results in t and a constant, and you're done. It's that simple, everybody. You don't need a substitution, and that's the key. Sometimes you do, sometimes you don't. In this case, if you make up two fractions, you don't need to. We want to integrate 5 plus 2 cosine d theta, cosine theta d theta. Pay attention to the fact d theta means the independent variable is theta, therefore 5 becomes 5 theta. And this becomes 2 sine theta plus a constant because the integral of cosine is positive sine. You have an exponential form. The exponent is a choice of u. Its derivative is 5x to the power of 4. du is 5x to the power of 4 dx. So if we move x to the power of 4 next to dx, we notice number 5 is missing. Because it's a number, you can throw in the 5, undo it with its reciprocal 1/5. And now you're looking at e to the power of u du with a 1/5 in front. Again, I put this outside. You can leave it inside. It makes no difference. This 1/5 is a multiplier. Anywhere you put it makes no difference whatsoever. And so e to the power of u, the derivative and the integral are the same. So 1/5 e to the power of u and a constant. Replace the u, you're done. Bear in mind, as always, if you differentiate the result, you should get the same thing without the dx. The integral of x sine x squared dx and the integral of sine squared x cosine x dx. I want you to see them next side by side, because you want to understand the process for each case. In this one, the argument has the exponent. That is the choice of u. Its derivative is 2x, therefore du is 2x dx. We rewrite this such that x is next to dx and number 2 is missing. Instead of solving for dx, I would just throw in the 2, undo it with 1/2. This is sine u, this is du. The integral of sine is negative cosine. So 1/2 times negative cosine u and a constant. And I put the negative in a different color to make sure that it's there. And replace the u with x squared. The final result is negative 1/2 cosine x squared plus a constant. If you differentiate this, you get this one without the dx. However, when you're dealing with part B, what is the difference? The difference is that you have sine and cosine as well. In that case, the one with the exponent, sine x has the exponent, is a choice of u. Don't write the exponent, just the sine x. The derivative is cosine x. Du becomes cosine x dx. The integral of u squared du uses the simple case of a power rule 1/3 u cubed plus a constant. U is replaced and we are done. 1/3 sine cubed x plus a constant. A similar question to that, but this time cosine has the exponent and sine doesn't. So it's similar to that. Which one has the exponent? Cosine, that is the choice of u. And the derivative of cosine is negative sine. Therefore, du is negative sine x dx. So when I look at this, I notice that this part would be du, except doesn't have a negative sign. So if I had a negative sign, I would be in good shape. So I put a -1 in, -1 out. Take a look. So you can put this in a parentheses, put a negative sign in, negative sign out. Their product is 1. We are in good shape. And this results in minus the integral of u to the power of 20 du. Using the power rule, you get -1/21 u to the power of 21 and a constant. And replace the u with cosine. The final answer is -1/21 cosine to the power of 21x plus c. Of course, the negative sign is at top or in front of a fraction bar, makes no difference. If you differentiate this, you got to get this one without the dx. So I think the 3 questions side by side, it's helpful to understand it with more details, compare and contrast. We are dealing with a natural log and integration. It is always natural log, which is the choice of u. Its derivative is 1/x. So du is 1 over x dx. You can write it as 1 over x dx or dx over x. And I want you to see both again, because if you're exposed to it, you want to understand both of them mean the same thing. To make sure we are in good shape, we're going to rewrite this that it becomes obvious as to what we have. We have ln x to the second power, and we have 1 over x dx. This is u squared, and this is du. So u squared and du. Again, we use the power rule. We get 1/3 u cubed and a constant. U is replaced with ln x. So we get 1/3 ln x to the third plus c. Please understand, ln x quantity cubed means ln x times itself 3 times, not the same as ln of x cubed. Two different things. You have a fractional format. It's a transcendental function. And you can simplify. Notice, if you differentiate e to the power of x, you get e to the power of x. If you differentiate e to the power minus x, you get minus e to the power minus x. That means the top is the derivative of the bottom. So you choose the bottom to be the choice of u. Du becomes the top times dx. We put the dx at top. So we have du over u. And this is a simple case of a natural log. So natural log of absolute value of u plus c. Replace the u. You should recognize this as a positive value. Therefore, you can drop the absolute value sign and put a parentheses ln of e to the power of x plus e to the power minus x plus a constant is the final answer. As always, you can differentiate the result. You get this one without the dx. We have ln x. That's a choice of u. So the integral of 0 to 1, ln x plus 1 over x plus 1 dx. You let u be ln of x plus 1. The derivative is 1 over x plus 1 times 1, or simply 1 over x plus 1. Therefore, du is 1 over x plus 1 dx. You don't have to rewrite it, but I like to rewrite it to make sure the reader can see. This is ln of x plus 1. This is dx over x plus 1, or 1 over x plus 1 dx. This is u, and this is du. And I'm not going to write the limits yet. I'm going to discuss the limits in a moment. The reason I'm not going to write the limits, because the old limits, the original ones, pertain to the variable x, not the variable u. And of course, this uses the good old power rule. So this is 1/2 u squared from the lower limit to the upper limit. So if I put the 0 here, I get ln of 1, which is 0. If I put the 1 here, I get ln of 2. And we're going to keep it as ln 2, which is an exact answer. So you put ln 2 first, and then ln 1 or 0 second. 0 doesn't do anything, so half of ln of 2 to the second power, which is an exact answer. Please understand this means ln 2 times ln 2. It doesn't mean ln of 2 squared. In other words, don't mix these two. ln 2 quantity squared is not the same as ln of 2 squared. Two different things. And normally in calculus, we keep it as exact, unless they ask you to put it in a decimal format with however many decimals they ask you. A bacterial colony increases at a rate of R of t equals 2.2 e to the power 0.4 t bacteria per hour. If the initial population is 800, find the population after 12 hours. So if this represents the rate of increase, that is the derivative function, so capital R of t, where R prime is lowercase r of t, represents the actual population. So capital R of t represents the population. Capital R prime of t, or lowercase r of t, represents the growth rate, with the initial population, capital R of z, equals 800. So we can use the accumulated change theorem or the net change theorem. The amount of increase would be the integral from 0 to whatever they say, in this case 12. So the accumulated change, the amount of increase in population after 12 hours, is the integral of 0 to 12 R of t dt. And so we are going to replace it with 2.2 e to the power 0.4 t. In the case of differentiation for exponentials, we multiply by 0.4. In the case of differentiation, we divide by it. So we're going to divide 2.2 by 0.4. And this is the same as 22 over 4, which makes it 5.5. You plug in the top limit 12. You keep the 5.5 out. It's easier that way. And then the bottom 0. Of course, this becomes 1 because it's e to the power of 0, but you have to use the calculator. So this is the approximation. Because we are dealing with the population, we want to go to number 2 to do so. In other words, round it to the nearest unit. Since next to it is 8, it goes up to 663. We had the initial amount of 800, add them up, and that's the final answer. I'm going to look at the second method, everybody. And that is finding the function for R of t. Since we've done the major part of that, the integration means you want to integrate this. That means this is the answer plus a constant. We also have the initial value R of 0 equals 800. That means if I replace this one with 0, this becomes 800. That's the meaning of it. Of course, e to the power of 0 is 1. This is 5.5. Subtract from 800, and you get 794.5. So here's your function. Now, we want it after 12 hours. We plug in 12. After 10 hours, 10. After 20 hours, 20. So the advantage of this is that you don't have to go through this process again. You just do it once. And if it has several parts, you can do it in one shot. It's pretty straightforward, everybody. We can model the rate of airflow into the lungs by the function f of t equals half of sine of 2 pi over 5 t liters per second, where t is the time in seconds. Find the total amount of air inhaled in one cycle, known as the tidal volume, if the cycle lasts 5 seconds. Remember, the cycle of 5 seconds contains 2 parts, in and out. So the time for inhalation is half of the cycle, 5 half seconds. The assumption is in and out, they are identical time, roughly 5 halves each. So total amount of air inhaled is the integral of this from 0 to 5 halves. So the integral of 0 to 5 halves, 1 half sine of 2 pi over 5 t dt. I put this in a different color because I want to make a point that this is a multiplier, whether it's inside or outside of the integral sign makes absolutely no difference. It's just a coefficient. So to integrate this, notice we're going to use the substitution by letting u be 2 pi over 5 times t. The derivative of this is 2 pi over 5, everybody. So du is 2 pi over 5 dt. So what we are going to do, we are going to rewrite this in the following manner. I'm going to put the 1/2 out. I'm going to say the integral of 0 to 5 halves sine of 2 pi over 5t. And I'm going to put the dt in a parentheses. The reason I'm doing that, so I want to compare it to this, and I see everything is in good shape. I just don't have 2 pi over 5, and 2 pi over 5 is a number. So I can put the 2 pi over 5 in, and then its reciprocal out. And again, you can put both of them inside, makes no difference. You can put this one here. It makes no difference. It's a number that will remain as a multiplier. The product of these two is 5 over 4 pi. This is sine of u, and this is du. And I'm not going to write the new limits yet because I cannot use the old limits. So the integral becomes 5 over 4 pi times negative cosine u. We got to figure out the limits. To figure out the limits, you plug in 0 into u, and 0 makes this 0. Class, 0 makes it 0. If I plug in the upper limit, I get 2 pi over 5 times the t. The upper limit is 5 halves, and we get pi. That's why we get everybody 5 over 4 pi. Sine gives us negative cosine. The lower limit is 0. The upper limit is pi. Let's put the negative sign out. So let's write negative 5 over 4 pi cosine of pi minus cosine of 0. Cosine 1 of pi is negative 1. Minus cosine of 0 is positive 1. This is minus 2. Negative and negative makes it positive. So you have 10 over 4 pi or 5 over 2 pi. That's an exact answer. And here's an approximation. If you go with 3 decimals, if you go with basically 1. And this whole thing was an approximation also. You always show the exact answer. Okay, the reason I'm writing the decimal, because this whole thing is approximated in science. The integral of 0 to pi over 2 1 plus cosine dt was done. The independent variable is t, so this is t, this is sine t. We put the upper limit minus, put the lower limit. 0 and sine 0, both of them are 0, so this is 0. And you should know this is 1. And the exact answer is pi over 2 plus 1. Exact answer. We're going to change this to x to the power of 1/2. This has exponent 1, so we get 5x to the power of 3 halves plus 3x to the power of 1/2. So this one becomes 5 over 3 halves plus 1, x to the power of 3 halves plus 1. And this becomes 3 over 1/2 plus 1, x to the power of 1/2 plus 1. We don't need a constant because this is a definite integral and the result is a number. 3 halves and 1. They add up to 5 halves. This is 2, 1/2 and 1 is 3 halves. They add up to 2. And now you plug in the upper limit 4 minus plug in the lower limit 1. We are going to evaluate this basic math. So 4 to the power of 5 halves is square root of 4, which is 2. 2 to the power of 5 is 32 times 2 is 64. 4 to the power of 3 halves is 2 cubed. It's 8 times 2 makes it plus 16 is to our 1. So the whole thing is 4 minus 4. Okay. And so we get 76 as the final answer. We looked at this in our lecture 25. We have a polynomial x, a polynomial under the radical 25 minus x squared. The more complicated one, 25 minus x squared, is a choice of u. Its derivative is negative 2x. Therefore, du is negative 2x dx. When we rewrite it, we notice everything is in good shape except negative 2 is missing. Since it's a number, can put it in there, undo it with its reciprocal negative 1/2. And now you write it in this format. I'm not going to write the new limits yet. Remember, the old limits pertain to the original variable x. This we've done it many times. It's u to the power of 1/2. We just did that in the previous page with respect to x. So this remains. This gives you 1 over 1/2 plus 1 u to the power of 1/2 plus 1. Resulting in 3 halves here, resulting in 2/3 as a reciprocal. The product of these two numbers is negative 1/3. And you can replace the u with 25 minus x squared and go to the original limits. But what would be the new limits if I plug in 3 here? Becomes 9. 25 minus 9 becomes 16. If I plug this in here, becomes 16. 25 minus 16 becomes 9. And those are the limits we are going to use. And so we plug in. So we keep the negative 1/3 out. And then u to the power of 3 halves, we replace the u with 9. Minus, we replace it with 16. 9 to the power of 3 halves is square root of 9 cubed, making it 3 cubed, making it 27, minus square root of 16, which is 4 cubed, 64, making it negative 37. The product of this number and this number is positive 37/3. A box with a square base and open top must have a volume of 32,000 cubic centimeters. Find the dimension that minimizes the amount of material used. First, let's remind everybody a rectangular solid with this width and length and height has a volume of product of the three, the width and the length and the height. If you look at the face in front, there's a face in the back, they're identical. Same thing for the side, same thing for the bottom. So we have 2 of each. So for gift wrapping, we call it surface area gift wrapping, the width times the length plus the height times the length plus height times the width, and there are 2 of them. If you have a cube, meaning all sides are identical, the volume becomes s cubed, surface area becomes 6s squared. In this case, let's define our variables. It's x by h. The reason it's x by x because it's a square base. So x by h. So the idea is to minimize the surface area. Normally, the surface area for this would be 4 walls that are identical. The reason is because x times h, since the base is square, x times h is the front face, and all of them are the same. So 4 of them, 4xh. The bottom has a area of x squared, so does the top, normally 2x squared, but it makes it open top 1x squared. So you want to minimize the surface area, which is 4xh plus x squared. Again, I emphasize 1x squared, not 2. What is the constraint? The volume must be 32,000. What is the volume? X. times x times h, x squared h must be 32,000. So this is understanding the algebra behind it, the geometry behind it. And so this has two variables, x and h. We're going to solve for h. We're going to put that into this, becomes a function of one variable, x, instead of two. When we do that, this x goes away, and this goes to x, or simply x to the power of 1. 4 times 32,000 is 128,000. And because I want to differentiate, I'm going to bring the x up, making it to the power of -1. X represents dimension, must be positive. That means I have the open interval of 0 to infinity. To differentiate this, I multiply this to, I get -128,000 x to the power -2 plus 2x. I will look at my critical points. So I'm going to rewrite this in the following manner. Actually, let me just keep this intact. Let me write it at the top of it. So I'm going to write this as negative 128,000 divided by x. When you do that, you take a common denominator is x squared, so this changes to 2x cubed at top. Please understand, if you divide this, you get 2x. Now, here's your critical point. It's 0 when the top is 0, and it's undefined or doesn't exist when the bottom is 0. The bottom is 0, x equals 0 is not part of the domain. So let's work on this. By moving this to the other side, we end up with 2x cubed equals 128k. Divide by 2, you get 64k. Take a cube root, you get 40 centimeters. Always write the units, everybody. Because it was cubic centimeters here for the volume. This is in centimeters. And so we have everything under control. We have an open interval. We have one critical point, so local becomes absolute. But is it going to minimize or maximize? We really have to justify it. And an easy way would be the second derivative test. So we're going to go back here. S double prime is the product of these two, which is 256,000 x to the power of -3 plus 2. And I can put the x to the power of -3 down, make it x cubed, and plug in number 40. Now, even if you don't evaluate this, positive over positive is positive, plus 2 makes it more positive. Of course, the answer is 6. Positive means concave up, looking like this. So the minimum occurs when x equals 40. So this proves this critical point will minimize the surface area, the amount of material we need. So if x is 40, what is h? You can use this one or this one. If I put it here, 40 squared is 1600, divide 32,000 by it, you get 20. And so the dimensions are 40 by 40 by 20. So those are the dimensions. And we are done. However, if the question asks, okay, what is the minimum surface area? You put x equals 40, h equals 20 into this formula, and it results in 4,800 centimeters squared.